Hello, everybody. I'm Abdouad Sabri from the Faculty of Science, Nahal Maraz, University Sidi Mohammed bin Abdullah of Fez. I'm going to present you our paper entitled A Robust Approach for Arabic Document Images, Segmentation, and Indexation. The paper is co-authored by Nouni Assia, Arab Abdullah, and me. Before starting, I would like to thank the organizing committee of this conference, Professor Moussoufi Badr and Professor Saad Mutahir, for giving us the opportunity to present and to discuss our work. The content of our presentation is as follows. I will start by an introduction of the document images, archiving and using issues. After that, I will present you the concept of document images analysis and then the problems behind the separation of text and graphic from document images. And I will present you the proposed approach followed by the simulation results, and at the end, a conclusion and possible perspectives. As you know, libraries contain a huge number of printed Arabic documents, which contain text and graphics, such as historical, religious, mathematical, and so on documents. So, to digitalize these printed documents, it is necessary to first isolate text from graphic and to use OCRs for text generation. The main question here and the main issue created is how to separate efficiently text from graphics. So we should first localize the text area and second, separate text from graphical components. In this paper, we present you a fast and efficient method for automatic text localization first and for word matching. And for word matching, sorry. Let's first define document images, which is the digitalized image version of each page. The content analysis and recognition from document images is a scientific discipline that brings together a set of techniques in the field of image processing. The main objective is to reconstitute the content of documents from their digitalized image in order to allow their later modification, archiving, research, reuse, and transmission. Describing the structure of a document consists in identifying each of the textual or non-textual components that constitute it. In fact, there are two types of structures: physical structure and logical structure. For physical structure, which describes its layout, defines the different text zones, their arrangement in relation to each other, as well as all their typographical characteristics, such as font, color, bold, italics, and so on. Logical structure describes the role and nature of each element of a document, as well as the hierarchical and or logical links that connect them to each other. Text separation from graphics is a major step in the processing of document images. It consists in splitting them into two layers, graphical layer and the text layer. Text layer contains semantic concepts about the document that can be used by a human or highlighted by an OCR, while the graphical layer contains all the symbols that can be complex depending on the application and on the content. Graphic layer itself is decomposed into atoms such as lines, curves, polygons, circles, and so on. For the text, It is composed of numbers and characters grouped in strings used to annotate the graphic. The process is as follows. To elaborate a successful text graphic separation, we can proceed as follows. The first step consists in the document image segmentation, which is seen as a challenge due to its component diversification, and at the end, word retrieval. The approach adopted for separating the content of a document image in textual and non-textual components is as follows. First, the document image is segmented into regions to identify graphic regions from text regions. And for each text region, we proceed by word segmentation and word features extraction at the end, and at the end, word matching. In the extraction and the separation of text from graphics in a document image, it is a complicated step, especially in the case of Arabic documents. We first start by the binarization. We propose to use the NIBLAC binarization, where a threshold is used for each page separately. After that, we proceed by labeling by segmentation the text regions and the graphic regions. In the word matching part, it is done by following the next steps. Segmenting the text region into words using the RLSA in the horizontal direction. We propose then to extract 5 features from each word. And at the end, word matching is performed using the DTW for dynamic time wrapping sequence comparison algorithm between query word and each of the words in the document image. Knowing that the DTW is based on the Euclidean distance. The first part of a word search system in an Arabic document image is the localization of words that are presented in the document. The figure below represents an example of word segmentation of a document image. We have fixed the value of 15 as a threshold value. This value is chosen empirically after several simulations. We also present the result of the application of the HLSA algorithm. The segmentation result is presented at the end. From the segmentation results, we could identify the different related components composing the word successfully. For the word matching, we propose to extract 5 features such as quantized histogram, upper and lower vertical profile, ink and non-ink transition, and the transition from the center. The DTW algorithm was adopted to identify the similar words. The extracted features will be subsequently used in the retrieval of a word in all document images. The figure shows an example of word retrieval application using the proposed approach. As you can see, our proposed approach was able to identify the exact matching of the query word in the document image. As a conclusion, we present an automatic approach for word matching and retrieval from document images. We first propose to segment the document image to separate the text from the graphical components. The text region is then segmented into several words using the HRLSA algorithm, and we propose to extract 5 features for each of the extracted words. These features are compiled using the TW algorithm to find the matched words for the query word. Here are some references we used. Thank you for your attention. Any question?